Hello and welcome back to EESC 315. This is Lecture 16, Significance Determination, which I've subtitled Science Meets Values. This is where it gets really tricky. We've done all of our hard work doing the science, doing the technical work, doing our assessment, and now it's time that we mesh that with values and try and come up with a significance determination that people will agree to. And of course that's tricky because we are now into the realm of values. And of course everybody has slightly different values. Some people have radically different values. And so trying to come up with a determination of what is significant will vary depending on who you are, what your background is, where you're from, and many other factors. And so it's our job as scientists to come up with something that is transparent, somewhat repeatable, and that other people will hopefully agree to, particularly stakeholders, regulators, decision makers, and others who will be affected by our impact assessment. So with that, I'll just quickly mention the background for today's presentation is the Peace River near Fort St. John. Of course, this is near the site of Site C, our case study. But moving on, most of what I'll be talking about today is really generic to EIA. It doesn't really have much to do with Site C. It has to do with every impact assessment that's ever been done. So I'm going to refer to some of the earlier papers that looked at impact assessment. So starting with Dwinker and Beanland's 1986. What's interesting here is that they recapped about 15 years of impact assessment, looking at some of the main concepts and some of the challenges to defining significance. So this was a really seminal paper. They set the stage for a lot of the work that was to come. Lawrence 2007, Ehrlich and Ross 2015, and now Noble 2021 look back at essentially the last 50 years of impact assessment. What's kind of interesting here is that things hadn't changed really too much in the past 35 years since the 1986 paper, although in the last year or two, things have begun to change quite a bit. And this is with the 2019 Federal Impact Assessment Act. And so that is touched on by Noble. Most of the material that I'll be presenting here today was recorded last year, and I have added some interesting notes that come out of the Impact Assessment Act from 2019 and from Noble 2021. And these are sort of updates to how significance is determined. So as I mentioned, over the past 50 years, things were relatively stable or constant, and it's only in the last year or two that we're seeing some fairly major changes to how we see significance. So in other words, for most of our literature and most of our practice, we've relied on some relatively transparent and repeatable definitions of significance, which is what I'll spend most of today talking about. But more recently, we are seeing a lot more reliance on global impacts such as climate change and impacts to treaty rights and other indigenous issues. So those are new, well, not completely new, but much more highly prominent in the recent acts. So these are fairly new. They haven't really worked their way through the impact assessment system yet. So most of our case studies will be related to the traditional definition of significance, which I will spend most of my time on today. So when I talk about significance, or when we see significance in an impact assessment, what do we mean? And this is the question posed by Beanland and Dwinker in 1986. So do we mean statistical significance? Statistical significance is usually defined by some statistical test, which is valid at some probability. Do we mean ecological significance? And if we do, what do we mean by that? Are we affecting ecological function, the resilience of the ecosystem? Are we going to extirpate or drive extinct some rare species? Are we going to affect biodiversity? These are all very important ecological conditions that we can use to define significance. Or do we mean social significance? Do we mean direct or indirect measures of human well-being? So last lecture we looked at human health impact assessment, but there's also stress that people can undergo if there's a major project in their area. There's lots of different social impacts, as we've seen in earlier lectures. What do we mean by significance as it relates to human well-being? And then we have project significance. Is there some decision that is so significant that it affects the outcome of a project? All of these are different factors that we need to take into account. Now, having said that, I'll transition back to the talk that I prepared last year, and I will pop in and out throughout to give a few updates. So on slide 4, I say that significance determination is one of the most important outcomes of an EIA, and that certainly depends on your perspective. Personally, I would say that the most important outcome of an EIA is to identify mitigation and to make sure that mitigation occurs. But certainly the significance determination is the most important part of an EIA with respect to whether or not that project will be approved or rejected. So from the standpoint of a proponent, the determination of significance really gives the proponent an idea of what absolutely must be mitigated, because the chances of getting a project approved, if that project is deemed likely to have significant adverse impacts, is low. So if the proponent can mitigate those impacts, most likely they'll go back and insert the mitigation and update the EIA. Now, for regulators, the finding of a significant adverse impact makes their decision very difficult because then they have to weigh that against the public good. And we'll talk about that near the end of this talk. But I'll just read a quote. So the focus of an EIA under CEAA 2012 is always whether the project is likely to cause significant adverse environmental effects after taking into account the implementation of mitigation measures. So that's really key. If a project is deemed likely to have significant adverse impacts, the proponent can go back, insert mitigation, and reassess before submitting, or actually they can do this after a submission if it's pointed out that there are mitigations that they should have considered that they haven't already considered. For stakeholders, this is a major decision point as to whether or not they are likely to support the project or oppose the project. And the question is really, are there significant adverse impacts to something that they value? So just to set the stage for how significance is determined, go on to slide 5, and I'm going to just read a couple of quotes from Ehrlich and Ross because I think they really encapsulate some of the big issues with significance determination. So despite this widespread centrality of the question of significance in EIA, straightforward methods for reaching significance determinations remain challenging and sometimes unclear. This is true even though there are many examples of EIA guidance that identify characteristics of a predicted impact that need to be considered in reaching significance determinations. So what they're saying here is that even though we have lots of guidance around how an EIA practitioner and a regulator should view and understand significance, there's lots of methods, and we'll go through some of those in this lecture. It's still really unclear how those need to be understood because essentially we start with scientific information, we then need to translate that into values, and values are subjective, they're not well understood, they're not well communicated, and some poor decision maker, some poor regulator needs to make a decision on behalf of lots of different parties, most of which or many of which can have opposing views. And all of these values need to be weighed against each other, considering all of the scientific evidence. So it becomes a very difficult undertaking for a regulator to make sense of all of this. And an EIA practitioner's job is to give the best scientific evidence and to try and put this in some sort of a context that regulators can then use to decide whether the project should be approved or rejected. This might not be clear at this point. You might want to come back and look at this slide again after you've been through the entire lecture because this is a really key thing to understand. A second key point that I pulled from that paper is as follows. The 5 characteristics listed in Canadian guidance, magnitude, geographic extent, duration and frequency, reversibility and ecological context, are widely cited and superficially appear to suggest that determinations of significance are a scientific exercise. We think not. And I definitely agree with them on this point because we start with scientific evidence, facts, data, things that we can quantify in terms of change, in terms of effect, And we need to translate that into something that we care about, something that reflects our values and really the so what of an EIA. And so these criteria are an attempt to bridge that scientific information with subjective values. The Ehrlich and Ross paper make a lot of use of the term subjective, and they are very clear to point out that subjective does not mean arbitrary. It simply means things we care about, not necessarily things that we can measure. So let's start with the scientific aspects of EIA and work our way into the subjective values. So on slide 6, I take us back to some of the endpoints that we try and assess in an EIA. So these are changes to the biophysical environment. There are lots of different possible changes that we might assess. This is showing some of the air quality, soil quality, terrestrial, water quality, and coastal impacts. Assessing any one of these can be a fairly complex scientific undertaking, and I've focused mainly on water quality throughout this course because that's my background and it's definitely easiest for me to teach it that way. And then everybody who's worked on the assessment project, either the modeling or the assessment side, should have a fairly good understanding of another technical component by now. And what I want to do in this talk is generalize those concepts in terms of significance. So to generalize it, we need some sort of a standard measure that we can apply to any one of these individual components, put them on a comparable ground that we can then compare in terms of significance overall. On slide 7, I'm showing a figure from Noble, and this relates to the prediction of an impact. This is generic. So what this shows conceptually is some variable, doesn't matter what it is. It's got some baseline level, which might vary slightly over time. Along comes a project, and we can make a prediction of what that variable would look like in the future without the project. We can make another prediction about what that variable might look like, how it might behave in the future with the project. And that's illustrated by the downward line, which in this case would be some sort of an adverse effect. So that might be a population level, could be habitat area, could be general overall water quality index. It can be really anything, stream flow values, something that's changing over time. And we can show fairly clearly that this is an adverse effect. But the term adverse simply means not good. It doesn't tell us how significant it is. Virtually any change in a negative direction can be adverse, but it can be very minor or it can be extremely large. It can be catastrophic. So the question is, where is that cutoff that makes it, quote, significant? Moving to slide 8, let's talk about the difference between effect versus impact before we even get into significance. So virtually any change can be characterized as some effect. For example, reducing the overall flow of the Peace River by 0.5%, that's an effect. Is it an impact? Probably not. It's probably not even measurable, but certainly it is an effect. The term impact is generally taken to mean any sort of an adverse effect. So both effect and impact can be determined scientifically, really without imposing much subjective thought or values upon it. It's only when we now have to determine whether it's significant that we rely almost exclusively on values. So as I've said here, effect and impact are largely scientific determinations of fact. These are things we can measure, these are things we can predict quantitatively. Significance, on the other hand, relies on those facts to make a subjective, but not arbitrary, decision that reflects values. And so I've referred to Ehrlich and Ross. They talk a lot about this, and it's definitely worth a read. And as they cite another study, they say that significance is more about valuing than calculating. So we do our calculating to understand effect and impact. We do valuing to understand significance. So let's go to slide 9 and think about this in terms of a concrete example. And so for this example, I'm using an air emission. So imagine we have some large stationary stack. This can be a smelter, concrete factory, oil refinery, doesn't really matter. We've got some large stack emitting pollutants up into the air. Pretty much any EIA will look at the chemical components of that plume coming out of the stack, which would include NOx, SOx, which lead to both acid rain and aerosols, which can cause respiratory problems, as well as PM 2.5, which are the very small particles being emitted, and CO2. But in addition to that, that emission will also have some sort of a thermal load. Almost certainly it will be warmer than ambient air temperature, and I've just thrown out some purely hypothetical numbers here just for discussion. So let's say ambient air temperature, that's the air all around us, is 20 degrees. Directly at the top of the stack, so this is essentially the air and steam and smoke and everything coming out of the stack, this is coming out at 90 degrees. As the plume disperses, it will cool and it will approach the ambient air temperature. So let's say 10 meters downwind, the plume has cooled to 40 degrees. At 100 meters, it's cooled to 21 degrees. And 200 meters downwind, it is still ever so slightly above ambient temperature. We can barely measure it. It's 20.001 degrees Celsius. So the scientific question that we can answer is, does it affect the air temperature? Absolutely. There's no question this is affecting ambient air temperatures. Okay, so then we can ask, does the air emission adversely impact air temperature? And again, this is fairly easy. Most of the time, if something is changing from a natural condition, we can just call it an adverse impact. But now we have a much more difficult question, which is the adverse impact significant? And assuming this stack is not directly in the flight path of some endangered bird, we can say probably not, but that's a very ambiguous response to that question that nobody's going to agree on. So we need to come up with some sort of a criteria that, even though there might be some debate over it, at least it gives us a starting point for determining significance. Before we move on to those criteria, going on to slide 10, I just want to quickly talk about something that Noble makes mention of, and that's secondary effects. So secondary effects are some usually adverse effect that is caused by the project, but not directly caused by the project. So in the case of a hydroelectric reservoir, the reservoir will cause flooding. The flooding will cause anoxic conditions. The anoxic conditions will cause mercury methylation. This can then lead to bioaccumulation in a number of species, including fish, which then get eaten by humans, causing neurological effects in humans. So this is a secondary effect. Similarly, with agricultural runoff, these are high in nutrients. The nutrients run off into a stream. The stream causes algae growth. Algae die. They take up oxygen, causing anoxia in the stream, killing fish. Again, this is a secondary effect. The agricultural runoff did not directly kill any fish, but this chain of events led to fish dying. And I think in the past, these were considered separately. However, I've never seen them in the last 15 years ever considered separately. Regulators and stakeholders do not care whether an effect is direct or secondary. Any effect caused by the project, whether it's direct effect or some long chain of effects, are considered as if they are directly caused by the project. So in terms of EIAs, they do not differentiate. Any effect caused by a project is the same as the direct effect. Okay, so let's go to slide 11 and talk about significance criteria. In order for everybody to agree, or at least to have a rational basis for discussion around what is significant and what is not, there are some general criteria that can be applied to each VC, and those include the direction, magnitude, geographic extent, duration, and reversibility. And so what does each of these mean? And some of them I'm going to go into a little more detail as we go. Some of them are pretty self-explanatory though. So direction, is it adverse or neutral? Adverse is anything really that is changing away from a natural state. Almost always any change is adverse. There are some changes that are positive, but these are almost never covered in an EIA because that's not what an EIA is for. And then the magnitude. How large is the effect? Again, we talked about very small effects earlier. That doesn't necessarily make them significant, but it helps us determine if it is significant in consideration with all of these other criteria. So geographic extent. So is it restricted right to the project location? Is it restricted to a local study area, which is usually a watershed or a range of a certain animal or something relatively close to the project? Or is it all over a regional study area? And the regional study area is usually set as the maximum possible distance away from the project where the project can have any effect whatsoever. And then we have duration. So is the effect going to be short term, which often means during the construction period or just the initial start of operations? Or is it long term, which often implies a project that lasts many years? Or permanent? And there are very few effects which are permanent, but there are some. A reservoir is a good example of that. Once the reservoir is flooded, even though the project is planned for 100 years, it's really not certain that that dam will come down and the river will be restored 100 years from now. This is more likely going to be a permanent reservoir. Another example that I've seen is a fairly catastrophic pollution event whereby a smelter had been polluting downwind, and the deposition from all of its stack emissions had completely destroyed quite a large area of land downwind, and that land is now essentially useless. That was a permanent effect. The next category is a little bit more difficult to understand, and that's reversibility. So that doesn't mean does the project stop and will it be reclaimed? It's really more about the ecology. Can the ecology recover? Is it resilient to change? Or is this something that, regardless of how long it lasts, it's actually going to irreversibly change the ecology of a region? And again, with a lot of projects, having it reversible does not mean it's restored exactly to its natural state. Usually what it means is it's functionally restored. So we have the same functional ecosystem, although not exactly the same species composition, but generally something that resembles what was in the region and locality before the project came along. So once we've attributed some value to each of these criteria, we need to put them together to come up with some sort of a significance ranking. And some EIAs do this qualitatively, some are quantitatively. The ones that are quantitative generally use some sort of an arbitrary number that scales these effects. It's often fairly similar to the options analysis we did, where we have 1, 2, 3, 4, 5, or 2, 4, 6, 8, 10, sort of numbers that reflect the scale or degree, but not necessarily proportional to the magnitude of the change. Now, going on to slide 12, we see some other temporal criteria that are listed in Noble. And the first one is actually a federal requirement, and that is timing. So does it correspond with a sensitive period? This is usually a breeding period, the rut, spawning, something where if you interrupt a certain ecological process during that specific period, you're going to have disproportionately large effects on the ecology. The next category is continuity, so whether the effect is continuous or intermittent. And of course, this has implications for the type of effect it can have, whether or not that effect is chronic or acute. And the next category is immediacy. And I haven't actually seen this one in an EIA because regulators and stakeholders tend not to really differentiate between something that happens now versus something that might happen in 5 or 10 years. It doesn't really affect the decision. So because it's a noble, though, I'll talk about it briefly. Some effects do differentiate between immediacy. So for example, methyl mercury generation, if a reservoir is built, we can expect to see methyl mercury generation a few years down the road. These are very slow processes. And there's also a category called teratogenic effects. These are things that don't affect the species or the individual themselves, they affect the offspring. And a couple of examples of that are selenium, which can affect the eggshells of particularly fish, and DDT, which affect the eggshells of birds. So if a bird is eating an insect that is bioaccumulated DDT, it may not even have a detectable effect on that bird itself, but when that bird lays eggs, the eggshells are too thin and the offspring don't survive. And another effect we can imagine is if some project goes along and disturbs some breeding grounds of some animal, even though it doesn't actually affect that animal at the time of the disturbance, when that animal goes to breed, it doesn't have the proper habitat, it will affect the reproduction rates, and sometime down the road we'll see those effects. But again, the decision makers and regulators, as far as I am aware, do not differentiate here. An effect is an effect, regardless of when it occurs. And the last two temporal considerations are related but distinct, so frequency and regularity. So the frequency simply describes how often, and the regularity describes whether or not it's at the same time every day or the same day every month, etc. But it's a predictable time, and the reason that's important, particularly for humans, is humans can avoid the impacts by staying away during those certain times. A good example of this is blasting. You can imagine the difference between a large construction site that has one blast once a month versus one that is continually blasting day and night. And of course, the regularity also comes into play. If everybody knows that the blast is going to occur at exactly 10 o'clock every day for the next month, you can stay away from the area, stay indoors, whatever. But the point is the more predictable they are, the easier they can be mitigated. And going on to slide 13, we see a few more criteria that are listed by Noble. This will depend on who's doing the EIA, who are the regulators, which jurisdiction this is done for. These may or may not be included. We've talked about direct and indirect. Although I've said this is not necessarily a criterion that regulators would look at in terms of decision making, although it could be in some jurisdictions, really this is something that is implicitly considered in the assessment itself. And the next category is nature or effect. This is also something that is more typically implicitly included. And what I mean by implicit is that the practitioner will make a scientific determination over whether an effect is additive or synergistic, but it doesn't necessarily need to be reflected in the criterion because what we really care about is that end effect, not really what type of effect or what's causing that effect. And the next few criteria we've talked about, but the last one is probability of occurrence. And so this is really reflected in one of two ways. One is just strictly a likelihood, which again can be qualitative or quantitative, and then it can be reflected in terms of risk. But in either case, we're talking about the future here, and it's very difficult to make any sort of an accurate statement around a probability of something occurring in the future. Typically, if we're doing something quantitative, our estimate will be really subject to the assumptions that we put into that calculation, and we really run the risk of overinterpreting some calculated probability as if that's the true probability, when in fact the true probability is going to be a function of many, many variables, most of which we have no ability to forecast in any sort of a quantitative way. Now I'll show a few case studies to give an idea of what this looks like in an actual EIA. And the first is on slide 14, and this is referring to the Mackenzie Valley Gas Project. And for some context, the Mackenzie Valley Gas Pipeline is a massive project which has been proposed a few times, and it has led to major changes in our environmental assessment procedures. Back in the 1970s, the project was initially proposed, and back then, environmental impact assessment is nothing like it was today. The project then went through a judicial inquiry, and Justice Thomas Berger had proposed a number of changes, which later really led to a lot of changes in our assessment procedures. Ultimately, that proposal was scrapped, but it was revived in 2004, and it underwent an entirely new environmental impact assessment process, this time under the more recent regulations and standards, and that's what we're seeing here in the case study by Noble. And so the table we see here on slide 14 is fairly typical of an EIA. We see the key indicators on the left, and we have the criteria listed across the top. And for each of the VCs or indicators, there is some indication about how each of those measures up against each of the criteria in the significance table. And along with any criterion, and this is probably the most important part, is a description of what constitutes a high, medium, low, negative, positive, etc. for each criterion. And these are shown on the right-hand side of this slide. So for direction, magnitude, extent, and duration, it specifically says what constitutes adverse, neutral, positive, low, moderate, etc., etc. And now the challenge with these criteria are that they must be generic enough that any VC can be categorized this way, but meaningful enough that regulators can actually make some sense of this in order to determine whether they believe there are significant adverse impacts. So a large part of an environmental impact assessment is often determining jointly among stakeholders, proponents, and regulators what are the proper criteria, how have they been applied. And when I say jointly, this is sometimes done in a hearing session, sometimes it's done collaboratively. But in the end, if all parties cannot agree on the criteria, there's very little chance that parties will then agree on the outcome of the EIA as a whole. One of the criteria that I want to talk a little bit more about is geographic extent, also sometimes called spatial extent. And we talked about this when we talked about baselines, because at the baseline stage, we haven't done the effects assessment yet. and it's very difficult to know what is that proper geographic extent for our study area. And once we've done our baseline, we're kind of stuck with that extent for the remainder of the EIA. And an additional challenge that I've referred to on slide 15 with regards to geographic extent is that we want to have a very large study area so that we're not missing effects. In other words, we want to set our study area large enough that any effects which are due to the project have either diminished or are somewhat negligible by the time they reach our study boundary. However, the problem here is that now if we have some effect which is related to spatial extent, the larger our study area, the smaller that effect appears to be in relation to our whole study area. And to illustrate this point, I'm going to use the case study of the Jackpine mine expansion. And you may have heard Kevin Hanna's talk last semester. It was held in the same room where we have our lab. And he had referred to a project that was approved despite having significant adverse impacts. And that was the Jackpine mine expansion he was referring to. And I remember that quite well since I worked on that project, although the issues we're talking about were not within my study domain. The contentious issues were really around caribou habitat. And this being an open pit mine will necessarily remove caribou habitat absolutely within the footprint of the mine and likely with some distance away from the fence line. Now going on to slide 16, you can see the approximate footprint of the Jackpine mine expansion. And you'll see immediately that this is surrounded by existing oil sands mines. So to the west, we have the Syncrude Aurora North mine. To the southwest, we have the Albion Muskeg River mine. To the east, we have the Curl oil sands mine. And directly south is the existing Jackpine mine, which is now being expanded under this assessment. And so at issue is how much caribou habitat will be removed and what effect that might have on caribou herds in the region. And so the footprint shown here, it's not the best diagram, but it's kind of approximate. It's about 100 square kilometers, which is very large, obviously. And this footprint will be completely unavailable to caribou for at least 50 years, just based on the life of the mine. So the question is this a significant adverse impact? At this scale, it certainly appears that way, but if you go to slide 17, this shows the same footprint now at the scale of the Wood Buffalo municipality, which is 62,000 square kilometers. So it's a very large area. And at this scale, the disturbance is 0.2% of the regional study area. So now, is that significant? And you can take that even further by considering the entire range of caribou, which goes all the way from the Mackenzie Delta to Lake Superior. So you can then consider the effects of a single project on an entire population. If you look at this at a very small scale, at a very narrow area, which is the immediate area around the mines, it's been found that the populations are declining by 5 to 20%. If you take it to the entire population as a whole, it would be a non-detectable effect. And so my intention here is not to describe whether or not this is significant, but simply to illustrate the fact that the geographical area has a huge impact on the determination of significance at the end of the day. In going on to slide 18, I'm going to use another example, again using fairly extreme bookends for a specific criterion, to illustrate how, on their own, none of these can really be considered determinants of significance. However, understanding the full context is really important for each VC. And when I said I'm using extreme bookends, I really am. So mule deer are everywhere. They're often overpopulated and sometimes culled because there are so many of them. So there's absolutely no chance that any project on its own could have any significant impact on mule deer populations. Now, despite that, it's entirely possible that mule deer could be a VC because they're edible. They're a common hunted species. People do care about them. So it's entirely plausible that they would show up in an EIA. Whooping cranes are the exact opposite. They were close to extinction, and there are many efforts to revive whooping cranes, which have been going on for decades. They're an extremely sensitive species, and one of the species that we care most about in terms of the Species at Risk Act. And now when we look at the predicted effects that the project will have on each species, we see that the project is predicted to have a high magnitude effect on mule deer and a low magnitude effect on whooping crane. And even though it's not specifically mentioned in the criteria, a decision maker would probably consider what Ehrlich and Ross had written, which is the Species at Risk Act has a prohibition against harming an individual of a threatened or endangered species, its residents, or its critical habitat. Violating this prohibition would be a significant adverse effect even if the regional population persisted. So, in other words, we might assign a low magnitude to effects on whooping crane, even though we have not even reduced one individual from the population. Simply altering their habitat to a mild degree could be a low magnitude effect. But according to Ehrlich and Ross, and this is a fairly common sense interpretation, this could actually be a significant adverse effect, even though if we just look at the criteria, it looks like a lower effect than the effect on mule deer, which would probably end up being a not significant adverse impact. So one of the main challenges with significance determination in EIA is that there are all sorts of small nuances like this that you really need the biological context for, and there's no way that government laws, regulations, and policies can cover every one of these possible circumstances. And as a consequence, there will always be a lot of room for debate over whether a specific effect is going to be a significant adverse impact or not. And so moving on to slide 19, I'm going to illustrate a little bit more around how this is done in an EIA, starting with the EIA level classification. So what I'm showing here is the overall effects classification criteria for the Tech Frontier project. And as you can see, this is not specific to any one VEC. The table starts with the generic criteria, so geographic extent, duration, frequency, reversibility, and magnitude. And within each of those criteria, it lists a few possible values. It then goes down one more level and gives a fairly basic definition of what each of those values means. And now keep in mind, this is still totally generic. Each VEC needs to be applied to these criteria. And so going down to slide 20, you can see for the water quality and aquatic health component, how each of the criteria are defined. And you may also notice that for each of these criteria, we have a number of numeric scores so that we can assign some sort of a relative ranking at the end. Now, I won't read through all of this, but in order to understand the following slides, you might want to just pause the audio for a minute and have a look at how each of these are defined. And moving on to slide 21, we see the next table in the EIA, which is essentially the same table without all of the descriptions, really now just showing the numerical scores. And you can see that in the end, the environmental consequence will be the sum of the numerical scores for each VC. And now moving on to slide 22, 23, and 24, this shows how the table was applied to 3 different water quality parameters, which in our case we can think of as VCs, although we didn't use the VC terminology for this EIA. And again, I won't read these, but I would suggest just pausing the audio for a minute, having a look at these to get a feel for how these are applied to a specific VC. Now, after each VC has been considered, we produce the table that is shown on slide 25, which is really just a summary of the environmental consequence for a number of different VCs. And I should mention that this table is applied after quite a bit of screening has already been done. For example, a lot of predictions are made through water quality models, which are compared to guidelines, compared to baseline levels, and a whole bunch of fairly numeric screening has been done before we get into this more rigorous level of analysis to understand the environmental consequence of any given VC. So I've talked now about how the proponent and their consultants will somehow arrive at some sort of a significance determination, but really what's important is how the regulator or the government does their determination, which is based in part on the proponent's analysis, but not entirely. So the government will read an EIA and they will consider the data and analysis and information in an EIA, but they don't necessarily have to agree with the significance determination that's put forward by the proponent. In fact, the government has their own process, and that was one of the readings that I had mentioned on the earlier slide. So they really have a 3-stage process to understand the significance. So the first step, and these are shown on slide 26, the first step is determine whether the environmental effects are adverse. And this part is pretty straightforward. The adverse effects are usually well laid out in an EIA. And as I mentioned earlier, these are scientific facts. Basically, they're not really up for debate around which values are at play. Something is changing from a natural condition. It's pretty clear if it's adverse. The next part is determine whether any adverse environmental effects are significant. And that's the difficult part that we've been talking about so far. And this is now when the government will have a look at the criteria that are used to determine significance, and they can either agree with those or they can come up with their own and reapply those criteria. And then the third stage is for the government to determine whether the significant adverse environmental effects are likely. So at this stage, everybody's agreed that there are adverse environmental effects and that they're significant. And this third stage to me seems very hypothetical. I've certainly never encountered a time when a proponent has put forward some prediction of adverse impacts. The government has found it significant, and then they've come back and said, no, this is unlikely. So I think this is almost a moot point. Virtually anything that's going to make it to the significant stage is going to be likely enough that it is a decision point. And now going on to slide 27, I'm showing the set of criteria that the federal government has, and this is again in that document that I've posted on Canvas. So for each VC, they want to see the magnitude, geographic extent, timing, frequency, duration, and reversibility. So this is right in their document. If you're doing a federal EA, you better have these things in there. You can have others, but this is definitely a minimum. And another key point from that document is the concept of a residual effect. A residual environmental effect is an environmental effect of a project that remains or is predicted to remain after mitigation measures have been implemented. So that's really key. As I mentioned earlier, really the two key points of an EIA are number one, to determine significance, but also to identify and implement mitigation that can reduce significant adverse impacts. And so the second half of this quote is the determination of whether a project is likely to cause significant adverse environmental effects relates to the residual environmental effects. And going on to slide 28, I'll just point out a couple of other things from that document that are important to consider. And the reason these are important is because as an EIA practitioner, you really need to be aware of what the government is going to be looking for. Otherwise, they'll send it back to you and tell you either to redo it or to substantially alter it. So the information and documentation is laid out in the EIS guidelines, which is the terminology that was used for Site C, but these are essentially a terms of reference. Another key point is that when addressing cumulative effects, you need to both look at the standalone project effects and the cumulative effects and do your determination on both. And they prefer to use benchmarks. We talked a lot about benchmarks in one of the earlier lectures where I went in quite a bit of detail about aquatic benchmarks. And I'm going to show some completely different types of benchmarks on the following slide. So I'll stay tuned and I'll come back to that. And then they need to see somehow that you've addressed the likelihood, and that could be quantitative or qualitative. And for this, you can see the Lawrence document. They talk about reasoned argument, collaboration, and risk assessment, as well as professional judgment. So the Lawrence document goes into a lot of detail about what those mean. And the last part is addressing uncertainty. And pretty much all EIAs address uncertainty, but how uncertainty is addressed varies tremendously. So for example, some EIAs might just have a table that says, here's some input value, here's the uncertainty that goes along with it, and here's what it means to our conclusions. And some projects might use a stochastic or Monte Carlo simulation to run many, many scenarios using a wide range of possible inputs to come up with some sort of a probabilistic estimate of the uncertainty of the project. But again, keep in mind that only tells us our known unknowns. There are all sorts of ways a project can fail. There are all sorts of inputs to a project that we can't possibly consider at the EIA stage because we can't predict the future. In any case, though, the minimum requirements for addressing uncertainty are laid out here. So we need to look at the accuracy and availability of baseline information, which often relates to the frequency, the spatial coverage, and the duration of the baseline program. And then the accuracy of environmental effects predictions, which relate again back to the baseline, plus the tools we've used, plus our assumptions, plus the limitations of our tools. And then the expected level of effectiveness of mitigation measures. Often mitigation measures are just assumed to be 100% effective, but in reality, that is not the case. Nothing is 100% effective. So in this case, what we should be doing is looking to other case studies to understand how effective our assumed mitigation has been elsewhere. And again, this can be quantitative or qualitative, but always keep in mind, even for a quantitative estimate, that only tells us our known unknowns, and it really can't tell us about all sorts of other things that can happen in the future. And we should really be aware of that and acknowledge that in our EIA. So going on to the next slide, I mentioned some other types of benchmarks and thresholds. So these thresholds can be applied to EIA for understanding the significance, but these are not the same types of thresholds I talked about earlier. So those are all really just health-based thresholds. There are lots of other thresholds that governments have set, that working groups have set, that relate to laws, policies, and other regulatory instruments. And again, I would pause, have a look at these because these can come into play if you're doing an EIA. So it's good to know what sort of other thresholds the government might be looking at besides the health-based ones that the scientist has proposed. And going on to the last slide, I just want to mention who the decision maker is. So depending on the severity of impacts, the decision maker will actually vary. Now, in a large EIA, often there is a recommendation for a decision, and that recommendation is made by a joint review panel, which is usually three very, very senior experts in the field of environmental impact assessment who have a large staff of scientists that help them make that decision, and they recommend a decision to the government. And the government now is either a minister, the governor and council, or cabinet. And for a project that is likely to have significant adverse impacts, it is the governing cabinet, which includes all of the ministers for whichever government happens to be in power at that time. And it's also important to note that having a significant adverse impact being highlighted as likely does not automatically lead to a rejection. And the Shell Jackpine mine expansion is a case in point there, where the government did determine that the project was likely to have significant adverse impacts, but the public interest outweighed those impacts. And you can see that the public interest considers social, economic, and ecological aspects, which is similar to what we've talked about in terms of the sustainability triad or the triple bottom line, which is social, economic, and environmental considerations. And since we're on the topic of tech frontier, this is essentially where we were just about to be when the government was due to make a decision and tech pulled out because they didn't want to be embroiled in such a controversy. And that was essentially going to be a cabinet decision that would have led to a lot of controversy. Some cabinet ministers were strongly for, some were strongly against, and there definitely would have been political fallout from that decision. And I've said it before and I'll say it again. I am very happy not to be the decision maker in these projects. I really love doing the science, but I pity the poor people who have to take it upon themselves to make a decision on behalf of all Canadians to balance the adverse impacts to the environment versus the positive impacts to the economy and to jobs and to people's welfare. It's an extremely difficult decision to have to make. And I'm back with some updates. I had just mentioned that the decision maker's job is extraordinarily hard. And as you can see here, we have criteria from the Impact Assessment Act of 2019, which actually makes it more difficult for the minister who must decide whether something is in the public interest. So I had mentioned the previous criteria, and now to that they've added the ones shown at the bottom of this screen. So the impact that the designated project may have on any Indigenous group and any adverse impact that the designated project may have on the rights of the Indigenous peoples of Canada recognized and affirmed by Section 35 of the Constitution Act, as well as Part E, the extent to which effects of the designated project hinder or contribute to the Government of Canada's ability to meet its environmental obligations and its commitments in respect of climate change. Now, those definitely sound like straightforward and logical and common sense things to consider. However, as always, the devil's in the details. So, for example, the extent to which the effects of the designated project hinder or contribute to the Government of Canada's ability to meet its environmental obligations and commitments in respect to climate change. So if a project contributes 0.01% to Canada's greenhouse gas emissions, is that significant? If they contribute 0.001%, is that significant? So while you might think that some of these criteria laid out in the Act might help the minister make the decision, these are actually just adding more difficulties for the poor minister to decide. So again, I'm glad I'm not the decision maker. I'm glad I'm just the scientist who gets to have fun running models and making impact predictions and doing some of the the numerical work that goes into these decisions and not the decision maker. Another thing that I didn't really touch on the first time around, this is from Noble's book again. This is the 2021 book, and that's the concept of vulnerability. So this applies both to ecological systems and to humans. So the degree to which an impact might be significant is highly dependent upon whether or not that impact is to a sensitive, either human or sensitive part of an ecosystem. So in other words, not all species are as sensitive as all others. There are always going to be more sensitive species in any environment, and there are always going to be more vulnerable populations in any human community. So what that means is, in the face of some impact, whether that's an impact to, again, humans or the ecology, some people or species will be resilient and others will be more sensitive. And there's also the concept of irreplaceability when we're talking about ecological systems. So for example, the Species at Risk Act is fairly black and white in terms of which species are at risk. But then we have human values that complicate matters further. So you can imagine there's a building development that's going to significantly and adversely affect a wetland. And what it's going to do is dry up that wetland, and let's say it's going to extirpate a mosquito species from that wetland. So would anybody care about that? Maybe. Probably some ecologists would care about it. If you were to ask the average person on the street, do you care that these mosquitoes will be removed from this wetland, and maybe this is a rare species of mosquito and this mosquito is now extinct? I suspect that virtually everybody you ask, outside of a small group of ecologists or nature freaks, would be quite happy with that proposition. However, then when you explain to them that that mosquito was the primary food source for a bat or a frog or a songbird or fish that everybody loves, or some other component of the ecosystem, and that component of the ecosystem is now at risk due to the loss of that mosquito, you would probably get a different answer as to whether or not people actually care. And so that's where values come into play in these decisions. Similarly, if you were to drive all the rats away from a certain area, I grew up in Alberta, where most people, when I grew up, were extraordinarily proud of the fact that rats had been extirpated from the entire province. It was a big point of pride until I learned about ecosystems and how that really will always have cascading effects no matter what species it is and no matter how much people hate that species. Extirpating a species is almost always going to have an adverse impact. So again, it comes down to values. It makes these decisions very difficult. And I'll just close by reading a quote that I read in Noble, and this is from Lawrence 1993, but it's a really good summary of the big challenge with determining significance. So significance is not so much the search for objectivity as it is the adequate substantiation of any subjectivity. In other words, it's almost impossible for us to come up with an objective set of measures that everybody will agree to in terms of what is significant. Our challenge as scientists is to document and be transparent about any subjective decisions that we make and any values that we attribute to anything. And it's more about showing our work, and hopefully people will agree with what we've done, even though everybody will have slightly different values. But at least this gives us a basis for helping the decision makers decide if something is in the public interest. I hope you've found this interesting. Me as a practicing scientist, I think this is probably the crux of all of environmental impact assessment. This is where we determine whether or not all of that work we've done is important. Thank you, and we'll see you in the next lecture.